Hello, welcome to Math Discussion. Let's talk about operations and composition of functions. But first, let's take a look back on operations on polynomials. Here are some examples. Number 1. Add 9c plus 3b minus 5a, and a plus 5b plus 6c. Let's arrange first the terms in the first polynomial alphabetically. We have negative 5a plus 3b plus 9c. Copy the second polynomial, a plus 5b plus 6c. Now, let's add the terms with the same variable. Negative 5a plus a. Remember, adding unlike sign will change the operation into subtraction. And copy the sign of the bigger number. The difference of negative 5a and a is negative 4a. Next, let's add 3b and 5b. 3b plus 5b equals 8b. Now, let's add the last term of each polynomial. We have 9c plus 6c equals to 15c. Finally, the sum of the two polynomials is equal to negative 4a plus 8b plus 15c. Number 2. Subtract negative 4ab from negative ab. To subtract the terms, change the sign of the subtrahend. Negative 4ab will become positive 4ab. Proceed to addition. Since the signs are not the same, let's subtract them and copy the sign of the bigger number. The difference of negative ab and 4ab is equal to positive 3ab. Number 3. Subtract 5a squared plus 6a from 2ab. To subtract the terms, change the sign of the subtrahend. 5a squared plus 6a will become negative 5a squared minus 6a. Notice that the variables of each terms are not common. If the variables are not common, proceed to copying all the terms in both polynomials. The difference of 2ab and negative 5a squared minus 6a is equal to negative 5a squared plus 2ab minus 6a. Number 4. Multiply the quantity 4a cubed plus 2 and 2a squared plus 3a. Multiply the first terms of each polynomials. 4a cubed times 2a squared. The product is 8a raised to 5. 2a squared times 2 equals 4a squared. 4a cubed times 3a equals 12a raised to 4. 3a times 2 equals 6a. Since the degree of the variables in each terms are not common, copy all the terms as well as the signs of operations. The product of the polynomials is 8a squared plus 12a raised to 4 plus 4a squared plus 6a. Number 5. Divide 50x raised to 4y raised to 6 by 5xy. First, let's divide the coefficients. 50 divided by 5 is 10. Next, let's divide each variable. X raised to 4 divided by x. This can also be written as x raised to 4 divided by x raised to 1. It is understood that x has an exponent, 1. Raising a number by 1 will have no effect on the number. To get the quotient of the variable, follow the law of exponents for division. Subtract the exponents. 4 minus 1. The result is 3. The quotient of the variable is x cubed. Next, get the quotient of the variable y. This could also be written as y raised to 6 divided by y raised to 1. Observing the law of exponents. Subtract the exponents of the variable 6 minus 1. The result is y raised to 5. Combining the coefficient and the variables will give you the quotient of the polynomials. 10 x cubed y raised to 5. Now, let's continue to the main topic. The operations of functions. Suppose we have two functions, function f and function g. The sum of functions f and g is represented by f plus g x is equal to f x plus g x. The difference of f and g is represented by f minus g x is equal to f x minus g x. The product of f and g is represented by f times g x is equal to f x multiplied by g x. The quotient of f and g is represented by f over g x is equal to f x divided by g x, where g x will not be equal to 0. Next, the composition of functions. Let's have function f and function g again. The composite function of f and g is represented by f circle g x is equal to f of g of x. The process of acquiring composite function is called function composition. Now, let's have an example. Suppose we have two functions. Function f is equal to x plus 2. Function g is equal to 2x minus 1. Find the following. Number 1, the sum of functions f and g. Number 2, the difference of functions f and g. Number 3, the product of functions f and g. Number 4, the quotient of functions f and g. Number 5, composite functions f of g of x. Number 6, composite functions g of f of x. Here is the solution to number 1. To get the sum of the functions of f and g, we will follow the form f plus g x is equal to f x plus g x. Now, let's replace each with the given functions. f x is x plus 2, plus g x is 2x minus 1. Let's remove the parenthesis. This will become x plus 2 plus 2x minus 1. By collecting terms with the same variables, this will become x plus 2x plus 2 minus 1. Adding each terms with the same variable will give you x plus 2x equals 3x. And 2 minus 1 is positive 1. The sum of the functions f and g is equal to 3x plus 1. Number 2. Let's have the form f minus g x is equal to f x minus g x. Let's replace them with the given functions. f x is x plus 2 minus g x is 2x minus 1. Let's copy the function f x plus 2 and change the sign of function g from positive 2x minus 1. This will become negative 2x plus 1. Now let's collect terms with the same variable x minus 2x plus 2 plus 1. Simplifying, this will become negative x plus 3. The difference of the functions can also be written as 3 minus x. To get the product of functions f and g, let's follow the form f times g x is equal to f x times g x. Let's replace them with the given values of functions. f x is x plus 2 times g x is 2x minus 1. Let's multiply them using the FOIL method. FOIL. F for the first terms, x times 2x is equal to 2x squared. O for outer terms, x times negative 1 is negative x. I for inner terms, 2 times 2x is 4x. And L for last terms, 2 times negative 1 is negative 2. By collecting terms, this will result to the product of functions and is equal to 2x squared plus 3x minus 2. To get the quotient of the functions f and g, let's follow the form f over g x is equal to f x divided by g x. Let's replace them with the given functions. f x is x plus 2 divided by g x is 2x minus 1. The resulting is the quotient of the functions x plus 2 over 2x minus 1. Let's have the composition of functions f of g of x. First, let's write down the function f x plus 2. Next, let's replace the x with the given value of function g, 2x minus 1. This will become the quantity of 2x minus 1 plus 2. Let's remove the parenthesis. This will become 2x minus 1 plus 2. Simplifying will give you the composite functions 2x plus 1. Let's have the composition of functions g of f of x. First, let's write down the function g, 2x minus 1. Next, let's replace the x with the given value of function f, x plus 2. This will become twice the quantity of x plus 2 minus 1. Let's evaluate using PEMDAS rule. This will become 2x plus 4 minus 1. Simplifying will give you the composite functions 2x plus 3. Now, we have all the answers to the problem. The sum of the functions is 3x plus 1. The difference of the functions is 3 minus x. The product is 2x squared plus 3x minus 2. The quotient is x plus 2 over 2x minus 1. The composite function f of g of x is 2x plus 1. G of f of x is 2x plus 3.